Before we get started with today's lesson, I want to do a quick review of exponents and exponent rules. Take a look at the first one, the quantity 2x squared, and think about what you should get for an answer. Hope you got that. Next one, negative 8m, that quantity squared. The next one, 1/4 y, that quantity squared. Three n squared raised to the 4th power. What does that give you as an answer? 3 to the 4th power is 3 times 3 times 3 times 3, which is 81. And then n to the second, I have 4 of them. So that would give me n to the 8th. Don't forget that you multiply the exponents together if you're raising a power to a power. So that should help you with the next one. And you should get b to the 6th. When I ask for a polynomial expression for the area, you would multiply those two binomials together. Pause the video, take a look. You should get that for the answer. Today's lesson is section 7.5, which is factoring special products. The first type of problem is called the difference of two squares. You'll notice that in those two terms that are in there, it's a binomial, but each of the terms is a perfect square. Notice that there's no term in the middle. So if I were to use my diamond, as I have been, my product, there's a 1 in front of the x squared, so 1 times 16 is a negative 16. And then the middle term disappears. There's nothing in the middle. There's no x term, so it's 0. So what two numbers do you think will multiply together to get a negative 16, but when added together would give you 0? Now we can go through and do the problem exactly as we've been doing it from before. So I'm renaming my 0x by using a negative 4x and a positive 4x, which would give me that 0 for the term. Group them like we have been. Take out the greatest common factor for each of them. And you'll notice that we end up with x plus 4, x minus 4. That middle term will completely disappear because x times x is x squared. This is a positive 4x, a negative 4x gives me 0, and 4 times a negative 4 gives me a negative 16. You try this one. Again, x squared minus 25. Both of those are perfect squares. You should know that a positive 5 and a negative 5 will give us the 0. Pause the video and get your answer. Final answer should be x plus 5, x minus 5. I hope you're seeing the pattern here because you really don't need to be doing this whole middle step. That whole middle step there, it takes a long time, and if you could recognize the pattern, it gives you a shortcut. Try this one. Just because they're both variables and there are no numbers there doesn't mean that you do anything different than what you've been doing. Did you get that for an answer? Now I want you to try this one. Notice that 36 is a perfect square, 16 is a perfect square, and x to the 4th means x to the 2nd times x to the 2nd. I could break those up and that's a perfect square also. The y to the 8th is also a perfect square. Y to the 4th times y to the 4th. Factor this and tell me what you get. Did you get this? If so, oh no. Look inside each one of these parentheses. If you look at each one of those binomials, there's still a common factor in there. I can take out the common factor of 2 in each of them and end up with 4, 2 times 2, 4 times 3x squared minus 2y to the 4th times 3x squared plus 2y to the 4th. What could you have done first that would have made this problem a little bit more simple? The next type of problem we have is called a perfect square trinomial. If you take a look at this problem, you'll notice that x squared and 16 are both perfect squares, but we have something in the middle this time. There is a middle term. So if I go to my diamond, as I have been, I know that 4 times 4 is 16, and 4 plus 4 is 8. Factor that. Factoring it gives me these two quantities, x plus 4 times x plus 4. But we're not done. And that's because since those two parentheses are the same, we write our final answer as x plus 4, that quantity, squared. This one has a leading coefficient that's not 1. But if you look carefully, you see that 9 is a perfect square, 49 is a perfect square. So look, I have 3x times 3x. That would give me the 9x squared. And over here, I have 7 times 7. If you take a look at the pattern from the last one, we know that we could pretty much go right to the parentheses if 3x times 7, which is 21, times 2 gives me 42, which it does. So here's my two binomials, and that's my final answer. Now, could you have done this by grouping like we had been? Of course you can, and you're going to get the same answer. This is what you would get for your answer once you found the answer by grouping, but don't forget that you have to show that it's squared. Try it by grouping and see if you don't get the same answer. You should. The last task for today is the lab. Good luck!